Alright, well, now that your warm-up's done, welcome to another edition of Mr. G's Manor Geometry Notes. Number 1 here for the warm-up. We have to find the length of the diagonal of a square is 15 square root 2 centimeters. We need to find the perimeter. So we need to draw a picture first. So the square, all sides are even. Alright, so these are all the same. And all the angles are right angles, right? So when we divide a right angle in half, we get two 45 triangles. Two 45, 45, 90 triangles. So that diagonal is also 15 square root 2, the length of that in centimeters. We need to find the other side, which conveniently, because we now have 45, 45, 90 triangles, we can find very easily. So the leg, remember from yesterday, or from the other video, is the hypotenuse divided by square root 2. Our hypotenuse is 15 square root 2. We divide it by square root 2, the square root 2's are going to cancel. So we're just left with 15. So our leg is 15, and our perimeter is going to be equal to our leg times 4. Or you can add it 4 times if you want to, that works as well. So 15 times 4 comes out to be 60 centimeters. That's it. Alright, for the second one, the side of an equilateral triangle measures 21 inches. We need to find the length of an altitude of the triangle. So, we have an equilateral triangle. All sides are equal. They're all 21. The altitude is going to cut this in half. It's also going to make this a right angle here at the bottom. So we now have two right triangles inside of their equilateral triangle. And because we know it's an equilateral triangle, all the angles are equally also. They're all 60 degrees. So we now have two 30, 60, 90 triangles. So knowing that means that whatever let's see, we're trying to find the length of the altitude. So we're trying to find L here. We have that our hypotenuse is the 21, and our side is going to be half of our hypotenuse. So h over 2, so 21 over 2, that's 10.5. To find our L, that's s square root 3. So L is equal to 10.5 times the square root of 3, which comes out to be an L rounded to the nearest tenth of 18.2 inches. And there we go. So today we're going to learn about trigonometry, specifically trig ratios like sine, cosine, and tangent. Those are all examples of trigonometric ratios. Also inverse sine, so sine is going to help us find one of the two sides, either I'll explain that in a second, but one of the two sides of a triangle, of a right triangle. And inverse sine will help find the angle of a triangle if you have the two legs, or all three sides of the triangle. Inverse cosine, same idea. Inverse tangent, same idea. And here they are. The trig ratios. So if triangle ABC is a right triangle with acute angle A, then the sine of angle A, written sine A, is the ratio of the length of the leg opposite of angle A to the length of the hypotenuse. So sine is equal to opposite over hypotenuse. If triangle ABC is a right triangle with acute angle A, then the cosine of angle A, written cosine of A, is the ratio of the length of the leg adjacent to the length of the hypotenuse. So cosine is adjacent over hypotenuse. If triangle ABC is a right triangle with acute angle A, then the tangent of angle A, written tan A, is the ratio of the length of the leg opposite of angle A to the length of the leg adjacent to angle A. So tangent is equal to opposite over adjacent. So we see our ratios all written there as symbols and our triangle given to us as an image. Now, the main idea here is all these these formulas, the symbols. So I'm going to put a whiteboard up and show you what really you need to get out of this. So the main ideas here are that sine of some angle we'll call theta. So first off, we need to draw a triangle. So here's our right triangle. Here's theta. A, B, and C. Those are sides. Or actually, rename those. So this is going to be opposite, adjacent, hypotenuse. So the opposite is across from it, right? That makes it opposite. Adjacent helps form the angle with the hypotenuse, and the hypotenuse is what's across from the 90-degree angle, your right angle. So sine is equal to opposite over hypotenuse. Cosine of theta is equal to adjacent over hypotenuse. So A over H, and sine is O over H. So tangent of theta is equal to opposite over adjacent, which is O over A. So now, if you notice, we have S from the sine, O and H, right? So actually I'm going to write this over to the right, so I have a bit more space. You get so for sine, opposite over hypotenuse. Ca for cosine is equal to adjacent over hypotenuse. Toa for tangent is opposite over adjacent. SOHCAHTOA, that's like PEMDAS, but for trig, okay? So what you do with this, now if you really need to, I like to remember just SOHCAHTOA, just like I like to remember PEMDAS. But PEMDAS also has, please excuse my dear Aunt Sally, to help you remember the order, right? SOHCAHTOA has something like that too, and I kind of mentioned that to at least one of you guys over in Miss Ween's classes, and I'll mention it to all my classes. But it stands for some old hippie caught another hippie tripping on acid. Oh yeah. Some old hippie caught another hippie tripping on acid. So if you really need that, it's there for you. If you don't, SOHCAHTOA is pretty good in of itself. It's kind of what I've always remembered. I didn't know some old hippie caught another hippie tripping on acid until I was teaching myself. One of my coworkers, when I was teaching in Bryan College Station, taught me that. She was teaching geometry and I was teaching physics, but still important in both classes. So this is the general idea that you need to get from the page I just showed you earlier, all right? So make sure you write all this down. This is very important. Write it down over and over again until you don't want to have to write it down anymore. And then write it down some more, because then it'll be in your head and you will not ever want to, you'll never forget it, basically. That's how learning happens, guys. You do things over and over again and you remember it. All right, so A, for example 1, part A, we have to find sine of L. Now, they just want us to find the ratio. So, all that means is get the fraction, put it into decimal, round to the nearest hundredth. It's pretty simple. So, sine of L, remember, is opposite over adjacent, right? So if we're looking at our triangle, here's angle L, not opposite over adjacent, opposite over hypotenuse. Opposite would be our 12, hypotenuse is our 37. So we got our opposite and our adjacent. So that's going to be 12 over 37, which comes out to be, if you put it in the calculator, 0.32 when you round to the nearest hundredth. Pretty simple, right? So now, next step is going to do cosine of L. Let's look at it. So cosine of L, remember cosine, SOHCAHTOA, and the K is adjacent over hypotenuse. So cosine of L, our adjacent, is what makes the angle that we're looking at. So L, 35 helps make that angle with 37 as the hypotenuse. So this is our adjacent, this is our hypotenuse. So that's going to be 35 over 37, which comes out to be 0.95 when you round. Next one, tangent of L. So tangent of L is equal to, remember, opposite over adjacent. So we already kind of labeled all these. This is our opposite, the 12, not adjacent, opposite. This is our adjacent. This is our hypotenuse for angle L. Opposite, adjacent, hypotenuse. So we're going to use opposite over adjacent, the TOA part. So that's going to be 12 over 35, which comes out to be 0.34 when you round the decimal. Alright, so now we're going to do the same thing, but now for angle N. Fairly simple, right? So angle N is up here. Our opposite now is the 35. And our hypotenuse is still the 37. Hypotenuse never will change no matter what angle you're going from. But you only got two to choose from. You're not going to ever use the 90-degree angle. You can't use that in there in our trig functions. Oh my God, having some difficulty trying to grab this wrist guard on this thing, so I won't write with the wrist as I'm writing your notes. So let's see, we got sine of N now is equal to our opposite, 35, over adjacent of 37. That fraction should look pretty similar because we just had it when we did cosine of L. That's the same exact fraction, and our answer is the exact same ratio. 0.95. So now again, we're going to cycle through all these again. So now cosine of N. So cosine of N is equal. So again, remember we shifted to the other angle. So now our adjacent is the 12. And 37 is still our hypotenuse. So K gives us 12 over 37, which again should sound familiar because that was our sine ratio before and got us 0.32. Now, notice that cosine and sine are opposites of each other, right? So if you're looking at one angle, the cosine is going to be equal to the sine of the other angle. Pretty cool, right? Now, tangent doesn't work like that because tangent doesn't have a buddy like that. Tangent's his own buddy. So tangent of N is equal to, again, if we look here, our opposite is the 35, our adjacent is the 12. So opposite's 35 over 12 now, which is the flipped fraction that we had for tangent before. So previously it was 12 over 35, now it's 35 over 12. And when you round, you get 2.92. So there we go. Done with those. Moving on. time to actually calculate some actual cosines and sines. So here we have the special right triangle, and we want to find the cosine of our 60-degree angle. So this is kind of a special thing that happens here with all the special right triangles. They all have special, unique things, especially once you get into pre-cal next year. So 60-degree angle here, cosine of that means we're looking at adjacent over hypotenuse. So cosine of 60 is equal to our adjacent x over our hypotenuse 2x. We cancel out the x's, and we're just left with 1/2, which when we round to the nearest hundredth, it's 0.50. And there's our answer. So this is very important once you get into trig and you start looking at these functions being graphed, knowing where they are when your cosine is 60, or when your angle is 60. Very important. All right? So, for our second one here, we need to find tangent of 60. So now, if you remember back to our triangle, for the 60-degree angle, our opposite is going to be the square root 3 side, right? So tangent of 60 is opposite, so x square root of 3 over our adjacent, which is just the x. So here, this is going to cancel, and we're left with square root 3 over 1. Which is our answer choice C. So even if you didn't get the decimal, be able to 1.73 in decimal form. So C is our answer. I know I'm kind of going fast on this, guys, but these are old notes, and you can rewatch this as much as you want if you need to. So, example 3, part A. So here we have a fitness trainer sets the incline on a treadmill to 7 degrees. The walking surface is 5 feet long. Approximately how many inches did the trainer raise the end of the treadmill from the floor? So, we got some issues here. Our walking surface length is in feet. We want our answers in inches. So we can go ahead and get our answer in feet and then transfer it, or we can change the feet to inches now if we want to. Either way, it doesn't matter. Our angle's 7, so we need to figure out which trig ratio we need to use to find what y is. Y is our opposite, right, to our 7-degree angle. The 5 feet is our hypotenuse. So this is our opposite over our hypotenuse, which means we're going to use sine. So, Katoa. So sine of 7 degrees is equal to our opposite, which is y, over our hypotenuse, which is 5. Now all we have to do is multiply by 5 on both sides. So this cancels on the right, the 5 anyway. So we're left with y being equal to 5 times sine of 7. You don't have to put a times in between if you don't want to. That's okay. Again, when you're doing this stuff, you need to make sure your calculator is in degree mode. So whatever calculator you were using, the odds are it has 2 modes, radian and degrees. Radians is great, but not in this class. We will not use that until at least we get to our circles unit, which is 2 units away. That's going to be unit 8 or unit 6. We probably will touch on radians in that unit, but until then, we don't need to worry about radians. So that means make sure that your calculator is in degree mode. Otherwise, you're going to get the very, very wrong answer. And especially if you get a negative number, your calculator is in the wrong mode. We should not get any negatives here. No negative angles, no negative lengths. So, we have 5 sine of 7. Hopefully by now you put in the calculator. If not, I already did. And it comes out to be 0.61 feet. We want our answer in inches, though. So what we have to do is take the 0.61, multiply it by 12, because there's 12 inches in a foot, and you end up with a length of, or a height of 7.3 inches. That's how high the treadmill was lifted off the floor. Well, the surface of the treadmill was lifted off the floor. Treadmill is hopefully still on the ground. Got one more like this. Next one here, we have construction. The bottom of the handicap ramp is 15 feet from the entrance of a building. If the angle of the ramp is about 4.8 degrees, about how high does the ramp rise off the ground to the nearest inch? So again, our length here is in feet. We want our answer in inches, so we're going to have to multiply by 12 at some point. But because it's 15 right now, let's wait till the end because it's not going to be very large at the end. Well, comparatively anyway. So, we have our angle here. The opposite side is our height that we're looking for. That's our adjacent, or opposite, sorry. We are given our adjacent, that's the 15. Don't have the hypotenuse, don't need the hypotenuse, and that means we won't be using anything but tangent, because so, both have h, they both use our hypotenuse, we don't have it, and we don't need it. So we're going to use tangent. Unless we have 4.8 equal to our opposite, which is what we're looking for, over our adjacent of 15. And once again, all we have to do is multiply by 15. So it cancels the 15 on the right, and we're left with our opposite of being 15 tangent of 4.8. And when you plug that into the calculator, we end up getting that our opposite side is 1.25 feet. And again, we need to multiply that by 12. So 1.25 times 12 comes out to be 15 inches, which should be D. There's our answer. Alright, so now the inverse signs. This stuff here is meant specifically to find the angle. Still got a few examples left to get through. So, I'm going to kind of skip around here, let you pause it where you need to. But so these are inverse functions, or inverse trig ratios. They are all used to find what the angle is. So if you're given two parts, you figure out which one you're going to use, find the angle using those. Now, inverse also can be arc. So if you're using Desmos, when you look at the functions button, there's a middle column that says in Desmos, on the functions button, under the stats tab, the middle column is the inverse trig functions. So all of these are on there, but they're listed as arc, tan, arc, cosine, arc, sine. It's the same thing as inverse. I don't know why we use both. Never looked up the reasoning behind it, but that's what they're called. So we're trying to find angle P in this example here. We have our adjacent side, and we're given the hypotenuse. So we need to use cosine, because it's the c. You have an A and H. So cosine of P is equal to 13 over 19. To use the inverse cosine, all we have to do is switch P and the 13 over 19 and make it an inverse. So cosine to the negative 1, or arc cosine on Desmos, is 13 over 19 equal to P. Now we can plug that into Desmos. It'll come out with our answer, and rounded to the nearest tenth, it is 46.8 degrees. Our next problem, similar idea. Let's see what we have so we can figure out what we need to use. So here's our D. So we're trying to find. Our opposite is 16. And our hypotenuse is the 23. So we have our O and H. So we're going to use the SO. We're going to use sine. So sine of D equal to 16 over 23, sorry. And again, same idea as we did before. Sine inverse of the ratio, 16 over 23, is equal to D. So D is equal to, after you put that into the calculator, rounded to the nearest tenth, it's 44.1 degrees. Which makes our answer A. For this one here, we need to solve the right triangle, which means we need to calculate every part of this triangle that we don't already have. We have two sides, we have the two legs, so we need to find the other side, which we can use Pythagorean theorem to do. And then we can use our sine, cosine, and tangent, whatever we want, to find our other two angles. Really, we can use tangent twice if we wanted to, but we could just use tangent once as well. So I'll show you what I mean by that. So our a squared plus b squared equals to c squared is basically our a squared plus o squared equal to h squared, right? So a here's either 7 or 4, doesn't matter. O is, again, either 7 or 4, since we already used 7. It's going to be a 4. And our hypotenuse we don't know yet. We're about to find that out. So 7 squared is 49. 14 squared is, or 4 squared, sorry, is 16, equal to h squared. We add those together, we get 65 equal to h squared. If we square root both sides, h is equal to the square root of 65. That's our h, which comes out to be, or the c in this case, which is 8.1. No units required. So there's our first thing. We now have this other side that's 8.1. Now we need the other two angles. We know one is 90 because it's a 90, it's a right triangle. So we got 90 down here to start. We need to find the other two. So first off, we can use tangent of A. Let's find A first. Equal to our opposite, which would be 4 here, over the adjacent, which ironically actually lines up with what I did earlier. I didn't do that on purpose. So tangent inverse of 4 over 7 is equal to A, and A comes out to be an angle of 29.7 degrees. Our last step now is to take that angle and our 90 and subtract them from 180. So 29.7 plus 90, all that subtracted from 180. So what we end up getting is our C, or our B, sorry. Ooh, that is a nasty looking B. There we go. So B is equal, after you do all the work here, 60.3 degrees. We've found everything we can find about this triangle. We got all three angles, all three sides, nothing else we can find out about it. So here's our exit ticket. Do the same thing we just did, basically, just different numbers. All right, and with that, that is the last notes for this unit. We will take our test next Tuesday, so if you're watching this now, hopefully you're reviewing for this test, okay? We're going to review on Monday, on the 30th. We're going to review on the 30th. We'll take our test on the 31st, and if you don't do too well, you'll get the ability to do corrections on Wednesday, all right? After that, we're going to start a new unit, and in which case I got to make more videos, all right? So hopefully if you're in Miss Ween's class, I apologize for all the struggles you guys have been having to go through, but if you need any help, again, I will be here for sure Monday afternoon for tutorials. If you need it, come by. I want a full house. I want my room to be full of people for some tutorials, okay? Not to be playing around either, but to actually learn and figure out how to do this stuff if you don't know already, all right? So with that, I wish you well. I hope you guys have a good weekend. Make sure you... you're not going to see this video unless you are watching the video, so I'm not going to say hopefully you're watching this video or hopefully you study, but See you next time.